In this video we are continuing the same journey. जो हमारा जर्नी है वो आज हम कंटिन्यू कर रहे हैं with the next part of the electron, that is charge to mass ratio. And again the credit and the experiment done by the same person, that is JJ Thomson, right? So just for the introduction I have to tell you that in case of discovery of electron and in case of charge to mass ratio experiment, there is some changes in the design of the cathode ray tube, right? So rest is same, but in electron discovery we have seen the perforated anode, but here we will see the anode with the center one single hole into it by which cathode rays will pass. And secondly, the electric field applied, right, for the all the passing means so cathode rays are passing and above and below they are providing the electric field as well as magnetic field perpendicular to the path of cathode rays, right? So this is the basic difference in this experiment and let's start with it, right? So this is the same tube, right? So आपको दिख रहा है बच्चों, this is the cathode, right? And these rays are coming from the cathode and going towards anode, right? And at anode, these rays are passing. You can see the deflection, some change in angle over there, right? And you can see over there same vacuum pump is applied over here for lowering down the pressure. Secondary battery for high voltage, and this is applied as a fluorescent screen. So everything is okay, but just this 2-3 parameters are there which are different than the earlier experiment setup, right? So now here they have shown the magnetic field, electric field. Here it is electric field and here it is a magnetic field. So this is what the simple change JJ Thomson has made for calculating charge to mass ratio. Okay, so let's go. In 1897, he measured the ratio of electrical charge to mass ratio. That's what we are dealing with, right? Charge to mass ratio using the same experiment as we have discussed, that is the cathode ray tube. By applying, this is what the change is. What he applied? He applied electric and magnetic field to the cathode rays, right, Victor? So this is what the cathode ray tube looks like, right? And let's have this setup over here. You can see over there. So this is a cathode ray coming, and this is the anode through which these rays are passing, and this is the magnetic field, and this is the electric field they have applied over here, right? Positive and negative charges are there for your electric field. So what he observed कि cathode rays जब पास होना शुरू कर दिए तो when electric field was applied, when only electric field was applied, so cathode rays hit the point A. कहाँ गए बच्चे cathode rays? A point पे hit किया. बाद में इलेक्ट्रिक फील्ड बंद करके उन्होंने मैग्नेटिक फील्ड अप्लाई किया. When magnetic field was applied, cathode ray hit the point C, right? And when he balanced, J. Thomson balanced both the rays. Which one? Both the A and C to B by adjusting the electric and magnetic field. He tried to make it cathode rays move in a straight line, right? So what he did, he adjusted the electric and magnetic field, right? So by adjusting that electric and magnetic field, the cathode rays passes straight to the point B, right, Bachcho? So this is what 3 changes J.J. Thomson did to calculate charge to mass ratio. ठीक है बच्चों? For in electric field hit A, in magnetic field hit C, and when there was a balance between the electric and magnetic field, it hit the point B. Clear बच्चों? So that's what here they have given. When only electric field applied, so deviate, so electron deviate from their path and hit the point A. This is the deviation. This is the deviation angle, right? By which, how much angle the rays deviate, right? So this was the deviation. So when electric field is applied, point A, when only magnetic field is applied, C, and by careful balancing the electric and magnetic field, it brings back the electron at point B. Clear बच्चों? Clear? कोई doubt इसमें? Good. Then let's move ahead. So now the deviation, as we have seen, that this angle, what is this angle, right? So ये angle कितना deviation होगा? मतलब this is the normal angle, right? Now at how much angle it will get deviated? So that deviation are depend on certain factors, right? तो कुछ factors है जो deviation decide करते हैं. So उनमें से पहला factor आता है magnitude of negative charge, कि इलेक्ट्रॉन या कैथोड रेज का नेगेटिव चार्ज कितना ज्यादा है. तो जितना ज्यादा मैग्नीट्यूड रहेगा उतना ज्यादा डेविएशन होगा. समझ में आया बच्चों? क्या होगा? जितना ज्यादा मैग्नीट्यूड होगा उतना ज्यादा, if this is the angle, right, and now if it is getting deviated, right, if somewhat less negative charge, it will deviate by this angle. If again increase the negative charge, it will increase by this angle, and so on. Right? So this deviation, right, depend on the magnitude of negative charge. Then most of the particle mass जो रहता है, अगर particle का mass light है, तो क्या होगा? You can easily change the direction. Right? Simple example लेते हैं, if a cycle and a car, right? अगर हमें ट्रैफिक में साइकिल चलानी है और कार चलानी है, and you have to reach at point A. तो बच्चों आप मुझे बताओ कौन पहले पहुंचेगा? If there is a traffic, so कार पहले पहुंचेगा या साइकिल? So answer is yes, you're right. So answer is cycle, right? So bicycle वापस जल्दी पहुंचेगा क्यों? Because of its mass. Same thing will happen over here. Mass of particle जितना कम रहेगा उतना deviation will be more. Right? So mass of the particle lighter the mass, greater the deflection. जितना lighter रहेगा उतना ज़्यादा वो deflect करेगा. जैसे लाइट बॉल, जैसे हमने एग्जांपल से एक बाइसिकल का लिया, तो बाइसिकल कैन मूव बाय दिस दैट कैन चेंज द डायरेक्शन, लाइक जहां से आप देखेगा वहां से मूव करके इट विल रीच द टारगेट, बट कार कांट. राइट? सो दैट्स व्हाट द सेकंड फैक्टर, मास ऑफ पार्टिकल, कि जो मास है उसका पार्टिकल का जो मास है वो कितना है. अगर ज्यादा मास है तो इजीली डायरेक्शन चेंज नहीं कर पाएगा, तो देयर विल बी lesser the deflection. ठीक है बच्चों? Then the third point is the strength of electric and magnetic field. तो आप इलेक्ट्रिक और मैग्नेटिक फील्ड कितना अप्लाई करते हो? बराबर? अगर सिंपल एग्जांपल है, अगर मैंने दिस इज अ नेल और मैंने छोटा सा मैग्नेट उसके पास लाया, तो मैग्नेट क्या करेगा? राइट? ही विल ट्राई टू अट्रैक्ट एट बाय जस्ट दिस 1 सेंटीमीटर और 2 सेंटीमीटर के पास लेके आ गया, सो ही विल गेट अट्रैक्टेड. बट वही अगर मैं स्ट्रॉन्ग मैग्नेट लूं तो ये यहां से भी वो अट्रैक्ट हो जाएगा. व्हाई? बिकॉज़ मैग्नेटिक स्ट्रेंथ इज हाई, मैग्नेटिक फील्ड इज मोर. राइट? सो दैट इज हाउ ग्रेटर द डिफ्लेक्शन इफ इलेक्ट्रिक एंड मैग्नेटिक फील्ड इज हाई. ठीक है बच्चों? अगर इलेक्ट्रिक और मैग्नेटिक फील्ड ज्यादा रहेगी तो उतना ज्यादा डिफ्लेक्शन रहेगा. इज दैट क्लियर? सो बाय एक्यूरेट मेजरमेंट अमाउंट ऑफ डिफ्लेक्शन, तो जैसे थॉमसन ने क्या किया बच्चों, उन्होंने जो एक्यूरेट डिफ्लेक्शन मेजर किया कि कितना डिफ्लेक्ट होता है, कितना वोल्टेज लगाने के बाद, कितना मैग्नेटिक फील्ड चेंज करने के बाद, हाउ इट गेट डिफ्लेक्टेड. सो उसका एक्यूरेट डिफ्लेक्शन उन्होंने मेजर किया, एंड बाय चेंजिंग द मैग्नेटिक एंड इलेक्ट्रिक फील्ड, एंड J.J. Thomson has given the value for charge to mass ratio is 1.758820 into 10 to the power 11 coulomb per kg. Right? So बच्चों लेट्स मूव एड कि अभी हम इलेक्ट्रॉन के बारे में जानना चाहते थे। तो जे थॉमसन जी ने हमें हेल्प किया टू नो अबाउट द चार्ज टू मास रेशियो। बट हमें सेपरेटली भी तो अलग से चार्ज क्या है और अलग से मास क्या है वो भी तो पता करना है, राइट? क्योंकि चार्ज टू मास रेशियो विल नॉट वर्क इन एवरी सिचुएशन। तो इसलिए हमें इलेक्ट्रॉन का चार्ज कितना है और इलेक्ट्रॉन का मास कितना है, वो दोनों चीजें हमें चाहिए अलोंग विद चार्ज टू मास रेशियो। सो उसके लिए व्हाट दे डिड, जे थॉमसन ने दिस डिड बोथ, राइट? चार्ज टू मास रेशियो साइमल्टेनियसली निकाला, दोनों फैक्टर अलग अलग नहीं किए। सो देयर वाज वन ग्रेट साइंटिस्ट सर्जन मिलिकन। सो मिलिकन हैज कैलकुलेटेड द चार्ज, जो अभी आगे हम देखते हैं, राइट? सो मिलिकन मेजर द चार्ज ऑन इलेक्ट्रॉन बाय फेमस ऑयल ड्रॉप एक्सपेरिमेंट। तो उन्होंने क्या किया बच्चों? he did ऑयल ड्रॉप एक्सपेरिमेंट, जो नेक्स्ट वीडियोस में अच्छे से पढ़ने वाले हैं, राइट? we will go into the detail of this experiment. तो he did this experiment and separately find out the charge on electron. क्या find out किए? charge on electron. who? Millikan. अब जे थॉमसन ने क्या किया? चार्ज टू मास रेशियो, राइट? चार्ज हो गया, नाउ लेफ्ट मास। तो मास के लिए क्या किया? कैलकुलेशन ऑफ मास बाय यूजिंग, so mass of electron can be calculated by Millikan's measured charge. मिलिकन जी ने जो चार्ज मेजर किया था डिवाइड बाय थॉमसन्स E by M रेशियो। थॉमसन जी का जो चार्ज टू मास रेशियो था, उनको अगर आप डिवाइड कर दो तो आपको मास ऑफ इलेक्ट्रॉन मिलेगा। ठीक है बच्चों, तो चीजें क्लियर हो गई। थॉमसन ने चार्ज टू मास रेशियो निकाला, मिलिकन जी ने इलेक्ट्रॉन का चार्ज निकाला अलग से, एंड देन बाय कैलकुलेशन वी कैन कैलकुलेट मास ऑफ इलेक्ट्रॉन, राइट? सो नेक्स्ट, तो हाउ ही डिड इट, what steps he took to perform these experiments, what the different values he has calculated. So this is what the Prayogam want. Prayogam don't want that this is the value, and but we want what actually experiment was performed, what actually things happen inside the cathode ray tube, how the force was calculated, how the acceleration was calculated, how the velocity was calculated. That will go in a Prayogam way, right? So let's go. So what is the step first? So first step was when cathode ray enter into the electric field. As we have seen earlier कि सबसे पहले जे थॉमसन ने क्या किया? He applied electric field, right? So that electric field क्या क्रिएट करेगा? इलेक्ट्रिक फोर्स, राइट? व्हेन इलेक्ट्रिक फोर्स अप्लाइड ऑन द इलेक्ट्रॉन, राइट? जो इलेक्ट्रॉन पे फोर्स अप्लाई किया इलेक्ट्रिक, देन ही फील द इलेक्ट्रिक फील्ड। उसने क्या किया? एक्सपीरियंस द इलेक्ट्रिक फील्ड, राइट? तो दिस इज द फोर्स and this is the electric field strength. F is a force, electric force, is a magnitude of charge on electron and again electric field E, right? तो बच्चों F is equal to EE. So यहाँ पे सबसे बड़ा रोल प्ले किया one of the great law, that is Newton's second law of motion, where we have seen force is equal to mass into acceleration, right? What he did? He bridged the gap. Second law of Newton ने क्या किया? He bridged the gap between observed deflection and Thomson's measured E by M ratio. Thomson जो यहाँ पे E by M ratio मेजर कर रहे थे और यहाँ पे डिवीजन हो रहा था, सो उन दोनों के बीच में का जो ग्राफ था वो that was bridged by second law of Newton. So force is equal to mass into acceleration, right? So let's put the value of force over here, right? यहाँ पे जो force है उसमें यहाँ पे अपने हमारा वैल्यू लिख देंगे mass into acceleration. So हमारा क्या वैल्यू आ जाएगा बच्चों? E is equal to mass into acceleration. By rearranging this, we can say E by M is equal to A by E, acceleration upon electrical strength, right? So from this equation again we can calculate the acceleration. So A is equal to E capital E upon M. ठीक है बच्चों? So हमें क्या मिला अभी? We have calculated E by M equation as well as we got the equation for calculating acceleration. Right बच्चों? Then step 2. Step 2 क्या था बच्चों? They have balanced what? Electric and magnetic field. So electric and magnetic field were balanced. So two deflection में cancel each other. बराबर? जो ऊपर A पे जा रहा था और जो C पे जा रहा था वो एक दूसरे को cancel करके दोनों B पे आ गए. Right? So electric field was balanced by the magnetic field. Right? So what is the equation become? E is equal to EVT. जो electrical चार्ज दोनों का कैंसिल होके इक्वेशन बनेगा E is equal to velocity into B, that is magnetic field strength. So from this equation we can calculate velocity is equal to E by B. तो अभी में by balancing by applying magnetic and electric field हमें क्या पता चला बच्चों? We can calculate the velocity of cathode rays, that is electron. Clear बच्चों? यहाँ तक की कोई doubt? Let's move ahead. So that's what velocity is equal to E by B. Therefore, by measuring the electric field and magnetic field, Thomson could determine the velocity of electron. Velocity of particles could be determined. तो जो भी मोहित पार्टिकल्स है उनका वेलोसिटी कैलकुलेट कर सकते हैं if we know the E and B, electrical strength and magnetic strength अगर हमें बताए, so we can calculate the velocity. Clear बच्चों? So velocity, acceleration, E by M, already we are done with it, right? So now just how to easily the things to memorize, right? So for memorizing it, let's have it. When electrical and magnetic, if both the fields are balanced, then velocity can be calculated. Velocity is equal to E by B, right? And when E alone means the first case जहाँ पे सिर्फ हमने इलेक्ट्रिक फील्ड ही अप्लाई किया था, right? वहाँ पे from E alone we can measure the deflection, right? Known velocity रहेगा, we can calculate A, acceleration. So this equation we have already seen E by M is equal to A by E. Where from this equation by getting the value of acceleration and electric strength, E by M value was calculated by JJ Thomson. ठीक है बच्चों? So कैसे लगा आपको हमारा जर्नी आज का? In the next topic we will move towards the Millikan experiment and later on we will go with the new discovery, that is discovery of proton. Be with us and enjoy the journey of science with Prayog. Thank you so much.